Welcome to Unit 3, Parallel Lines. The first lesson is on lines and angle pairs. There are only three ways that two lines can intersect. The first option is for the lines to lie in the same plane and never intersect. These are called parallel lines. The second option is for the two lines to intersect in a single point. These would be intersecting lines. The third possibility is for the lines to not intersect, but only because they are on different planes. These lines are called skew lines. For example, this line and this line do not intersect, but that's only because they are on different planes. Look at the figure before. Stop the video and see if you can name a pair of parallel lines, intersecting lines, and skew lines. Once you've done that, start the video again. There are several correct answers for each one of these, but for example, a pair of parallel lines could include line AB and line DC. We would say that AB is parallel to DC. AB would also be parallel to EF, and it would actually also be parallel to HG. We also have a lot of sets of intersecting lines. Any pair of lines that cross each other would be considered intersecting lines. For example, EF would intersect DE. There is no symbol for intersecting lines. Now let's talk about skew lines. If you think of that picture as being a classroom, what you're looking for with skew lines are lines that exist on parts of the room that do not meet. For example, on the ceiling and the floor, those two planes would never meet. So for example, DC would be considered skew with FG. Again, there are several possibilities, but that's one of them. If you're not sure if you've done it correct, ask your teacher in class the next day. A lot of what we do in geometry is not simply looking at one figure, but it's the relationship between them. So let's talk about lines in this respect. A line that intersects two or more lines is called a transversal. When this line intersects two other lines, it creates five special angle pairs. We're going to study these angle pairs in depth. Angles within the figure are considered interior angles, because they are inside the figure. And if they are outside the boundary lines, they are exterior angles. Look at this figure. I want you to label the transversal and the boundary lines. Since the transversal has to intersect two other lines, the one I have labeled is generally what we would call our transversal, although eventually all three of those lines will intersect the others. The next thing we want you to do is shade the interior and exterior regions using different colors. This is so that you can visually see what we're talking about. I've used yellow for the interior region and the light green for the exterior region. Notice that there are two pieces to the exterior region. The next thing we want you to do is name the four interior angles and the four exterior angles. Stop the video and restart it once you've listed these angles. You should have angles 4, 3, 6, and 5 as interior angles and 1, 2, 7, 8 as exterior angles. Now let's look at the five special angle pairs I referred to earlier. Alternate exterior angles are angles that are outside the boundary lines and on opposite sides of the transversals. You can use the name of the angles to kind of help you remember where they are. Alternate means it has to cross the transversal. Exterior means it has to stay outside the boundary lines. Name both pairs of alternate exterior angles. Since angle 1 is an exterior angle, it would have an alternate exterior pair. If I went to the opposite side of the transversal and stayed outside, I would get to angle 7. So angle 1 and angle 7 are exterior angles. Angle 2 is also an exterior angle, and if I cross the transversal and stay outside, I get to angle 8. So angle 2 and angle 8 are also exterior angles. Alternate interior angles are similar because they have to cross the transversal, but this time they have to be interior angles. See if you can use what you understood about alternate exterior angles to name the two pairs of alternate interior angles. Stop the video and restart it when you've named these angles. You should have angles 4 and 6, as well as angles 3 and 5. So far, so good. The next type of angle is a same-side exterior angle. These are angles that again stay outside the boundary lines because they're exterior angles, but this time they're going to be on the same side of the transversal. So, for example, since angle 1 is an exterior angle, if I stayed on the same side of the transversal and picked up an exterior angle, it would be angle 8. So angle 1 and angle 8 are same side exterior angles. Similarly, angle 2 and angle 7 would also be same side exterior angles. Same side interior angles are going to do the same thing, except these would stay inside the transversal. Take a minute, stop the video, and name the two pairs of same side interior angles. You should have angles 4 and 5, as well as angles 3 and 6. In some places, you will also see same side angles referred to as consecutive angles. You need to be familiar with both same side terms as well as consecutive terms. Our fifth special angle pair is called corresponding angles. These are angles that are in the same relative position to the two boundary lines. One will be an interior angle and one will be an exterior angle. For example, if I'm looking at angle 1, that is above my line and to the left of the transversal. So I'm going to go to the other cluster of angles and go above the line to the left of the transversal, and I find angle 5. So angle 1 and angle 5 would be corresponding angles. They're basically in the same place if I picked up one cluster and set it on top of the other. Another pair of corresponding angles would be angle 2, which is above the line again, but to the right of the transversal, and that would match up with angle 6, above the line to the right of the transversal. See if you can name the other two pairs of corresponding angles. You should have angle 4 and angle 8 as corresponding, as well as angle 3 and angle 7 as corresponding angles. Alternate interior and exterior angles, same side interior and exterior angles, and corresponding angles all have to choose an angle from each cluster of angles. By cluster, I'm looking at the angles that are formed when the transversal crosses each one of those lines. But we studied angle pairs already that fall within a cluster. For example, linear pairs and vertical angles. Stop the video and see if you can name the 8 linear pairs that are in this figure, as well as the 4 pairs of vertical angles. Remember that a linear pair should form a line. For example, angles 1 and 2, whereas a vertical angle should share only a vertex. For example, angles 1 and 3. Check your identifications and see how you did. It's important to note that vertical angles and linear pairs will all be formed within a single cluster of angles, whereas alternate interior and exterior, same side interior and exterior, and corresponding angles will be formed using an angle from each of the clusters. Time to see how well you understand this. Stop the video and go through the problems on the next 2 pages. You're going to be identifying the type of angles listed, followed by identifying the transversal used to form the angle clusters that are listed on the next page. When you've done that work, start the video again to check it. Check your first page and see how you did. Now check your second page and see how you did. Great. Time to move on to your Tier 1 activity on your Math Excel. Use the sheet on the next page to keep track of your work if you need to do so. and make sure that you get through the knowledge check before class.